Hello guys, welcome to our next video in the playlist Google Earth Engine for the beginners. So in today's video, we're going to see how we can resample a raster dataset. So we are going to use a CHIPS dataset. So it is nearly 5000 meter resolution data. So we will resample it to 10-meter resolution and we will visualize this in QGIS. So let's just start with importing our dataset. So you just search for chips dataset, so CHIRPS chips dataset. So I'm going to use the daily dataset. You will have two kinds of chips dataset for the climate hazard center infrared precipitation dataset. So this particular dataset will have the precipitation data. So it's been working for more than 30 years now. So they will release at two versions, so one at a pentad and one at a daily. So this particular dataset will give you the average rainfall for 5 days, and this one will give you the rainfall in terms of daily. So the units will be in terms of per day. So if you go to the penta data set, it will be per pentad, that is for 5 days. So here you will see we have only one band that is named as precipitation, and the resolution is 5,566 meters, so which is nearly 5 kilometers, 5.5 kilometers. So we will bring this spatial resolution to an 10-meter resolution so that we can work with it with a compatible Sentinel-2 dataset. And if you have any kind of analysis that involves some kind of climate input, so that you can resample it and you can use it in your analysis further. So if you see the description, so it says again the same at a 0.05 degree resolution, so that's approximately 5.5 kilometer in terms of spatial resolution, and the chips dataset is covering for now more than 30 plus years. So starts dataset availability from 1981, and it's a global dataset. So you just have to import this, and you rename it as chips for your understanding. So again, I want to have my region of interest. So I'm going to use the FAO global administrative unit layer. So it is the second level administrative unit. So we just have to import this one and rename it as FAO. So I have shown this particular dataset in my previous videos. So this particular dataset has the administrative boundaries at a second level administrative divisions. So for example, for India, it will be districts. So we're going to use the Kodagu district, and you need to copy some property so called as admin2 name, so that we will use the filter function and we will get the administrative boundary for this region of Kodagu. So just copy that property and let's just start. So first we'll create one variable called region of interest, that is our will be Kodagu. So for my region of interest, I'm gonna filter my FAO dataset with the function of dot filter dot filter dot equals to, so the property which I have copied, that is admin2 name, that is the property, and it should be equal to Kodagu. So just to print this in order to see we have our shapefile or not. So yeah, we have one feature collection. So it has one feature. So if you can just expand it, you'll get the properties of 12 properties. So here you will see the admin O name or the admin 0 name, that is India, and admin 1, that is the first level administrative division, that is Karnataka, and the second level administrative division, which is the Kodagu at a district level. So we have the shapefile now. So we will add this to map and we will zoom it and we will further resample it. So let's just start it. So map dot add layer ROI. I want to style this with the function of dot style function. So I want to have my outline color as black, and my fill color to be transparent. So that is the octocode for the shapefile. So just rename it as ROI, and now I want to have map dot center object to ROI. Just click on the run. So you will get your region of interest, the Kodagu added to map, and your map will be automatically zoomed into your region of interest once you run the script. So for now, let's just add the chips data set to it. So if you want, you can zoom in further, and you can get the zoom level from this inspect column, so that you will get the zoom level at 8, so that here you can have zoom level at 8, so every time the zoom level will be remain fixed. So now I want to create one more variable called rainfall. So this is my chips data set which I want to filter for my bounds called region of interest, and I also want to filter it for date with the use of function dot filter date. So I'm using the 2024 June dataset to 2024 6:30, so that I will get the entire month June median rainfall, and also you can take the median composite of it, not median, so mean. So I'll get the average rainfall, and you will clip to your region of interest. So yeah, that's it. Your rainfall for the month of June is ready. We just add it to map with the help of map dot add layer. So I want to have the minimum values to be 0, so now which will now will change later, and maximum to be 1000 mm. So since we are taking mean, that much will not be enough, so we'll take 100. And the palette, let's just say palette I want it to be red, yellow, and green, blue, so anything you just give it. So whatever you have, the initial colors will be having the low rainfall regions, and as the yellow will have the medium, and green will have somewhat good rainfall, and blue will have the extreme good rainfall in those regions. So you just rename it as RF simply for rainfall, and click on the run. So yeah, maybe you can remove this green and simply have the blue. So just expand it to 100%, so that we'll get the accurate range, and click on apply. So here you will see my pixelated image at a 5.5 kilometer spatial resolution. The range is from 5 mm per day to 30 mm per day. So you just adjust this to 5 and 30. So here you will see my uh, pixels are quite seen here, so they are not impressive for the client if you are projecting something. So I want to resample it to be smooth, so let's just do that. So we are using one function called dot resample. So you just go to documentation and search for resample. So this will apply to an image, not for the image collection. Remember, this has to be an image. So if we can just open this function, you will get the description for it. So it will take one input, that is the mode. What is the mode of resampling or the compression you want to apply here? So here you will see the description for this algorithm. So it will return an image identical to its argument, so which uses either bilinear or the bicubic interpolation, so rather than the default nearest neighbor. So whatever you are visualizing now in here, this is the in the nearest neighbor resampling mode, so that will be default in terms of QGIS also. But if you want to have the bilinear compression or the bicubic interpolation, so you can use it with the help of resample. So you just have to specify in which mode it has to be. So by default the mode is by bilinear, so it is usually good to go for the bilinear rather than the bicubic, so you will get the proper interpolations and the projections are also important. So it will compute the pixels in the projections other than the native projections. So it just we will use this one function, and we will see how does it work. So you create a variable called resample. So for my RF, that is my rainfall dataset, which is at 5.5 kilometer. So I'm just gonna use the function dot resample. That's it, my resampling is done. You add it to layer with the function resample map dot add layer. So minimum will be 10 and maximum will be 30. So this range might change because now we have the newer pixels where we have done the interpolation. So you would just also give the palette to be red, yellow, and blue, and you can rename it here as resampled. So click on the run. So somewhat we need to clip it out. So this resampled version doesn't work good in the Google Earth Engine. So we need to export this to my QGIS portal. So if you can just run it, so uncheck this RF1, so you will get the resampled one. So there you will find it has somewhat the transparent outlook in here. You just stress the range to 100%. Now you see the range has changed from 11 to 19. So you just switch to satellite mode so that you will get the pixels clearly. So here you will see my resample version is there. So it has been very much smooth, but only thing is that it is not visualizing properly. So there is some kind of opacity problem with visualizing this chips data after resampling. So what we have to do is that, so the algorithm has worked correctly, so you just need to export this to your drive with the user function export.image.drive, and you need to check it out in the QGIS. So the image I want to export is the resampled one, and the description I want to give is this resampled chips dataset. So folder anything you want to give, so you can give. So you have to specify the region to be your region of interest and scale to be 10 meters. So remember, you can give any scale in here, so that will be the output. So if you are working with the Landsat dataset, you give the scale to 30 because it works on the 30-meter resolution. So if you're working with the Sentinel, you give the CRS to be 10. So you give a scale to be 10. So now the CRS is to be EPSG 32642. So that is for India, and CRS transformations is not needed. So max pixels, if you want, you have to give because it's quite a large region of interest. The entire district is there. So in order to avoid the error, give the maximum pixels size to be 1 raised to the power 13. Show remaining shard size and file dimensions are all not required. So file format, priority, so everything is not required. So you just have to close it here and click on the run. So you'll get a new task here asking for the export to run. So you just have to give the run here and click on the run so that you will get it to export into your drive. So I have already exported this one, so I will show you directly in my QGIS what will be the output after exporting. So you just switch to your QGIS. So here I have my QGIS layout. So if you have here your resampled chips type file is here, so I have exported it. So here you will find our beautiful data set, so which is now resampled and it has been very much smooth. So the values, if you come to layers, so here you will see the higher values have the white ranges, so there the parts of the Western Ghats which gets more amount of rainfall. So as you go towards the plain regions, the rainfall decreases gradually. So if you want, you can go to single scalar band. So here you will see the higher values, red color on the part of Western Ghats, medium precipitation on the lower plains, and in again in the plainer land, so you have the less number of rainfall. So make it more useful, make it more interpretable, you just switch it so that you will get blue color in the precipitation range. So how smooth it is as compared to the original chips data, which was at 5.5 kilometer. So like this you can resample any kind of data set, either Modi's data set, the Terra aqua vegetation available at 250 pixels, 250 megapixels, so that you can resample and use it in your analysis further. So if you want, you can also open this properties. So you will get here the size. So just see the size of this image, 139.15 MB. So it's just whatever will be in the KBs, it's now in the MBs. So that's will be the quality of the TIFF file you're exporting. And here you'll also find some of the information like a pixel size. Here you will see the pixel size is 10 by 10, which indicates it's in the Sentinel-2. The resample has worked properly, correctly. So the CRS, which I have specified, 32643. So if you want, you can have it in the WGS 844326 CRS. So I hope guys you have understood how to resample any particular data set which have a large spatial resolution like a 5 kilometer, 10 kilometer. You can easily implement it with the help of Google Earth Engine just in one simple code dot resample. So you can also specify the bilinear or the bicubic interpolation, which one you want. So from this you will get what you want at a 10 meter per resolution pixel. So I hope guys you have understood how to do this. So if you have any kind of queries, doubts, or anything, you can always post it in the comment section. So thank you for watching.